back, everybody. Now we're going to be talking about the absolute value and how can that be blended into various functions. For instance, if f of x is equal to absolute value of x minus 5 divided by x squared minus 6x plus 5, and maybe the goal is to graph it or get it into a simpler form. What we need to do first is we need to remember that the absolute value of a number is either just that number if the input is positive or maybe 0, and it's minus that number if the input is negative. This can be generalized for any sort of absolute values. For instance, this absolute value of x minus 5, this can change into x minus 5 if the inside of the absolute value is positive, therefore x greater or equal to 5. Notice that if x is greater or equal to 5, then x minus 5 is positive. And it becomes minus x minus 5 if x is smaller than 5. All right? Therefore, this function f of x can change using the absolute value as follows. F of x equals, it's going to become a piecewise as we call it. And if x is greater than 5, I can replace the numerator with this. So the fraction becomes x minus 5 all over x squared minus 6x plus 5. And this is if x is greater than 5. And it becomes minus x minus 5 if your x is smaller than 5. Right? Now, we got to be a little bit careful with the denominator. All right? The denominator can actually be factored. So let's go ahead and factor the denominator. It's a trinomial, and you're looking for two numbers that multiply to 5 and add to minus 6. Those numbers are minus 1 and minus 5. So really, your function can change into this. X minus 5 over x minus 1, x minus 5, or minus x minus 5, x minus 1, x minus 5. And this happens when your function is greater than 5, and this happens when your function is smaller than 5. But now notice that my function is not defined at 1 and at 5. Therefore, if I really wanted to write this one up as a function with its domain, I should write it like this. X minus 5 over x minus 1 times x minus 5. If x is smaller than 5, sorry, if x is bigger than 5 but not equal to 5. And we're removing the value 5 because that makes the denominator 0. Now, the other form, x minus 5 over x minus 1, x minus 5, but with a minus here. This is true when x is strictly smaller than 5, and actually we have to somehow skip over 1. So the best way to write it is x smaller than 5 and x not equal to 1. And I have excluded 1 because that makes this part of the denominator 0, therefore the whole fraction does not exist there. Okay, so if you notice closely then, you can simplify your function because there is a cancellation. You see this x minus 5 over here with this x minus 5 over there goes away. And similarly, these two go away. So really, your function becomes f of x equals 1 over x minus 1 if your value is strictly greater than 5, and minus 1 over x minus 1 if your value is smaller than 5 but not equal to 1. So we managed to rewrite this function, this formula, into a piecewise formula that doesn't have absolute value, and it seems a little bit simpler. In the process, we also found that the domain is all numbers except 5 and 1. All right? Your task then would be to graph this thing. And we want to go over there in the graph and graph these two guys. And I noticed that x equals 1 is a vertical asymptote. If you want to check vertical asymptotes, look at the corresponding module. So x equals 1 is a vertical asymptote. I will graph it here. And this one tells me that for x greater than 5, somewhere over there maybe, I think this is 5, your function looks like the 1 over x minus 1, which is this guy right here. But the thing is, I need this part to start after 5. Let's say 5 is here. Therefore, I need to start from this point and on, and I don't really need these p's. Okay, so this is my function after 5. Prior to 5, my function is minus 1 over x minus 1. So minus 1 over x minus 1 looks like so. And again, and as you can see, it doesn't touch the x equals 1 axis. Now, let's figure out what that point is over there numerically. All right? In order to figure that one out, we have to figure out what would the function be if you could plug in the 5. We agree that 5 is not in the domain, but if you were to plug in 5 to this reduced form, you would get 1 over 5 minus 1, 4. So that point over there is basically the point 5 comma 1 over 4. And we put an open circle because it doesn't really take that point, right? 5 is not in the domain. What about this one? Well, again, if you plug in 5, you get 1 over 5 minus 1 gives you 4, so minus 1/4. So that point over there is the 5 comma minus 1/4. And again, that point over there is open. Open circle means it's not included. Okay, so this is the graph of the function that we're trying to compute. It has open circle here, and it tends to infinity. It goes to 0 when x tends to infinity, 0 when x goes to minus infinity, vertical asymptote here, and a little jump over there.